Hi, everyone. We will get started with this session. Thank you all for joining today. Uh, so this is session number 3. As you can see, we are discussing API literacy, and this program has been supported by IEEE Region 10 Educational Activities and IEEE Bangalore section. This particular whole program has been organized by IEEE Mangalore subsection, which comes under IEEE Bangalore section. And I'm Mohit, the chair of IEEE Mangalore subsection, talking to all of you. We will get started by quickly looking at the background, a quick minute as to what we have done, just in case if there are some people who are new today. We had our curtain raiser session for this program on 22nd July. The recording is available on YouTube. And we had immediately on the next day, session 1, wherein we introduced APIs and we also introduced the Postman classroom program. The recording is again available. Then we had session 2, which was held last Saturday, that is July 29th. The recording of that is also available. And all of them, you can get it through subscribing to our YouTube channel. And then the statistics as on date is that we have 100 plus participants. To be precise, just 5 minutes back when I checked, we had 104 participants who have completed the Postman classroom program successfully. Congratulations to all of you who have received a digital badge from Postman. And as promised, we will also be giving you a hard copy of the certificate from KOSH NITK, which is Center for Open Source Software and Hardware, which will be done at a later stage once we get started with the project competition. And if you have any doubt related to this whole program that we have started from July 22nd, and you don't know what is this program about, please feel free to reach out to the email address that is mentioned here. Moving forward, I would like to take a minute to talk about some very important points for this session. These are very, very serious points, and that's why I'm taking a bit of time talking to all of you on this. First of all, the content that I'm going to cover in this session today, it will be using a remote test bed. Some of you might not be aware of what is exactly the meaning of a test bed. So test beds are basically some experimental setups where a few machines are kept reserved for doing research activities. You can perform experiments on those machines and then collect the results and analyze them to understand whether whatever work you are doing, it is bringing some better performance or not. So test bed means you test your experiments, and then once you are successful, you go out and deploy those solutions in bigger market, right? So if I have to give you a very, very simple example, any internet service provider, for example, before they launch their internet services, like for example, we have Jio, Airtel, Vodafone, Idea, so many of them. So before they would go to any city and launch themselves, they would do a strong survey. They will see where they should deploy the base stations. They'll identify all that. They'll come back after identifying the location, and then they'll sit and decide, okay, where can we actually deploy our base station so that maximum people will get the network and very good speed. And they can also have some small machines set up on which they can actually perform these experiments. So these experimental setups, which are set up, these things are called test bed. First thing I would like to tell you is that please do not attempt to create an account on the websites that I'm going to show today without any appropriate context. I'll tell you why. If you just wait for 2 minutes, you will understand. So please do not create any accounts today. Don't hurry. Don't try to follow me when I'm giving the demo today. This is, for your benefit, and you will understand why am I saying so. The reason I'm saying so is in the second main bullet that you see that access to these remote test beds will require creating an account. It's free. Anybody can create an account. Preferably, you should create an account through your institutional email address only. That means your college might have given you an email address. You can use that. IEEE also has an email address. If you have not created an IEEE alias for your email, please create an IEEE email address alias, and then you can probably try to use that. Don't try to use things like Gmail or Yahoo Mail or other privately owned email addresses. Try to create accounts through institutional email addresses only. And that too, I would very sincerely request all of you to please take support from your faculty members when you're performing activities on these experimental test beds. Please do not try to do things by yourself, because if you are trying even genuinely, and you end up doing a mistake, your entire institution domain name can get blacklisted if you do not follow the rule. It's not so scary the way I sound right now, but we have seen certain institutions by mistake they did certain things, and then we had to request and tell that it was not intentional, it by mistake it happened. And you will understand throughout this session when you listen to me as to why they are so serious about following the rules. So always have a faculty member with you, always have a reason for why you are creating an account, and see to it that after you create an account, you use it very ethically and sensibly. Please don't try to put any malicious things on these test beds, because they'll track you, and if they track you and find out, then in future, nobody from your institution would be able to use these test beds. And if you wait for another 15-20 minutes, you would see how beautifully these test beds have been set up, and such a nice facility has been made available to all of us for doing research. And all of this is free. Trust me, many researchers actually rely on these test beds on an everyday basis for conducting their research. I myself had a PhD student who graduated 2 years back, and all the work that he did was using this test bed, which I'm going to show you today. So we never had to buy any hardware. We did not buy Arduino boards. We did not buy Raspberry Pi boards. We did not buy any hardware. More importantly, there was pandemic also, so hardware was not so easily available. So these are some very important test beds, and we should see to it that we don't play around with them in a incorrect way. So please take care of it. That's why I wanted to have one slide dedicated to important points. Coming to the agenda for this session, which is session number 3, and also the last session in the training. First of all, I will talk about OneLab. It's written as the way as you see in my slide. It's written ONELAB, O capital, L capital. So it's a lab which is in Europe, and I'll show you the website also. Do not try to search by yourself and try to log in and to do stuff. As I said, control your emotions, control your eagerness. Just be with me. I'll tell you the procedure. Go back, form a team, talk to faculty, and then slowly get things. They are not running away. The websites are always open. Throughout the year, you can become a member anytime. It's free, no charges involved whatsoever. So there's a concept called future internet test beds, and you will often see this word repeating in the whole session that I'm going to speak today. And then I'm going to use the word FIT. So FIT means future internet test beds. And then we will see the specific lab in OneLab. So in OneLab, there are many labs that I'm going to show you today, but I'll be just showing you the names of those. I'll take you in detail of only one lab, that is called the Internet of Things lab, which is called IoT-LAB. And it's a really very large scale IoT test bed. And you will see in a moment as to why it is large scale. Then I'll also show you a small demonstration in that IoT-LAB test bed. I will perform experiments right in front of you sitting from here. And once you people create an account after talking to your faculty and you understand that this will be useful, maybe you will also be able to perform the experiments from just by using any browser in your system. Okay. You can also use a phone and do the experiments. That easy it is. And then the whole reason we have this session today, where I'm talking about FIT, I'm talking about IoT-LAB, you will see that where is the word API used, because this session is for API literacy. So in comes the most important point. We are going to see what are the APIs that have been made available by the IoT-LAB team. And in fact, they have provided an entire API documentation. They have used the REST architectural style. If you were there in my previous session or had gone through the YouTube video of the session that we had on July 29th, you might have heard me speak about 4 different architectural styles. I spoke about REST, then I spoke about SOAP, I spoke about GraphQL, and finally I spoke about gRPC. And here, this entire IoT-LAB team has provided APIs, which are REST APIs, and we will walk through that documentation. And I will also go and open Postman, and I'll show you how using Postman, I can make a call to their APIs, which are available, which are set up in the machines in France. Okay, so we'll do that. And that's how this whole session is actually connected with API literacy. The ultimate message that I want to give by conducting this session is that APIs can actually be used to control hardware that is at remote locations. It's not just useful for fetching web pages or data from sources like Twitter or Facebook, or for only fetching such kind of information from these websites. No, you can actually remotely control hardware, which is miles away from you, thousands of miles away from you, but you can still operate on that hardware and extract some meaningful results out of it. So that's the whole purpose of this particular session. So going forward, this is OneLab. This is a snapshot taken from their website. This is actually the homepage of OneLab itself. And you can see on the left-hand side below the logo of OneLab, they have written future internet testbeds. And the reason they have written as plural, that means testbeds, is because they have many of them. And we are just going to discuss one. We are going to discuss only IoT. But I'm going to show you which are the ones that they support. And then see what they have written. They say your easy access to computer networking testbeds. They have world-class testbeds that they have made available. And all that you need to do is you need to create one account. Now, please believe me, don't try to create an account today. Don't try to do it right now. They are going to do verification even after you send a sign-up request. They are going to take your email address. They're not going to immediately approve it. Okay, they'll take some time, like 24 hours to approve it. So don't create an account right now. Just wait, listen to me, go back, think whether you need it, whether you want to tell your faculty members, or if there are faculty members today listening to me right now, do you want to create an IoT lab? Because I can see that particularly in the state where we are, the universities that we work with, they are introducing specific bachelor's programs on IoT. And this would be one of the lab that I would want to always introduce because it's totally free. I can allow my students to work on them. Students can work on them from their home. They don't need to be waiting to buy hardware, or they don't need hardware to be provided by the institute. So let me open up this website first of all in another tab, and then as usual I'll need support from all of you to confirm that you are able to see this particular tab. So just give me a minute. I have switched over the tabs. As soon as you start seeing the tabs, please raise your hands in good numbers so that I can see a lot of people are able to see it. All right, I can see some 6-7 people have raised the hands. Can some more people raise hands just to quickly verify that I'm coming through clearly and you are able to see? Okay, I can see only 6 people till now. Okay, 17, great, that's fantastic. Okay, thank you everyone. Just wanted to see that everybody is able to take a look at it. So now you can see this is the same snapshot which I had taken. I'm not going to show you how to do that because it's very easy. You can just give first name, last name. But as I said, please don't do it today. Take my words very seriously and please follow them. And then I'm going to click on this button, which is called services. You can sometime when you are free, just glance through the user stories and news and team. But for today, what is important for us is to look at services. So now when I click on services, of course, there are some important points, but you can see they have these 4 kinds of testbeds right now. One category they have made is called Internet of Things testbed. Let me just try to zoom in a bit so that it's easy for all of you. So you can see the first category is Internet of Things testbed. Second is wireless Internet cloud testbeds. Then there is software-defined networking. Then there are some network emulation experiments that you can perform. Okay, so these are testbeds. And there's a customer support also. So for example, if you need any assistance when you're performing the experiments, you can contact them over email and they'll assist you. And my PhD student used the IoT testbed, which I'm going to discuss today in a moment. So we got actually very good support from them. Within 24 hours, on weekdays, we used to get reply from them. And my student was able to make good progress and he never had to buy any kind of hardware. So now if I show you the high level of categories of what are the different testbeds that they provide, you can see that there's a category called Internet of Things. There are 2 testbeds that they have. The FIT here stands for Future Internet Testbeds, which you can see here below the logo. They have written Future Internet Testbeds. So that's the full form of FIT. IoT, it is Internet of Things, and it's a lab. So they call it as FIT IoT-LAB. And this is a clickable link actually here. When I click on it, it will take us to the FIT IoT lab, but I'm not going to click on it right now because I'm going to discuss that anyways in detail in this session today. So there's no need to jump onto that at this point. Below FIT IoT lab, you see there is another one lab, which is called W-I lab. That is also a lab which is for Internet of Things. Then apart from these 2, if you take a look at on the right-hand side, you will see there is a category called wireless. So you can also access any of these 6 testbeds that you are able to see the names below in the bullet points. You can see Fit Wireless Paris, because that lab is in Paris. There's another one which is called Fit R2 Lab. Then there is NIT OS. Then there is Fusico. Then again, the one that you saw on the left-hand side, w-ilab.t, it's not only an IoT testbed, but it is also supporting wireless testbed. So it is, that's why listed on both the sides, left as well as right. And then there is Cortex Lab, which is again a wireless network. And when we speak of wireless networks, you can see it covers Bluetooth. You can see at the top in the paragraph, it is written, it covers Bluetooth. You can actually perform Bluetooth experiments. You can perform Wi-Fi experiments. You can perform cellular experiments like 3G, LTE means, 4G. So all these experiments can be performed, and you don't need to actually invest anything into hardware. You just need internet connectivity, browser, and interest to work on all these things. So there are two categories that you saw: Internet of Things, wireless. Let me scroll up and show you two more categories. If you want to, let us say, performing experiments on internet level at a global scale, again, they have two separate experiments. You can see that their platforms have 300 servers, which are located at over 150 locations in Europe. And there are some categories like premium users in this lab, because this lab is a huge one. So users with premium access can also launch their experiments on additional 700 servers at 350 locations worldwide. For free, we can probably use those 300 servers and 150 location, but if somebody becomes a premium member, then they can use it. But we don't need to go towards a premium site. There's no need for us to do it, because we are doing all at educational level, right? There are two labs. One is called Planet Lab in Europe and the Virtual Wall. These are the two for the internet category. On the right side, you can see there is a separate lab called Cloud, which has cloud-based platform and OpenStack. There are 5 labs over there. The first one is called FIT. Again, I'm repeating, FIT full form is Future Internet Testbed. So FIT Cloud Lab, FIT NC Lab. There is Fusesco, which we saw earlier also. NIT OS was also above there earlier for wireless category. And the OpenStack one is coming soon. It's in the bracket, you can see. So these are for cloud. And then there is another one, very high-level networking paradigm, which is called software-defined networking. We call it as SDN. Some of you might have not heard about it. That's totally fine. But there are 4 labs that support it. So FIT-NC, Virtual Wall, NIT OS, and Planet Lab Europe. All 4 we have seen earlier also. But you can see that there are fantastic test beds that are available. They have very nicely set it up for them. However, there are some new technologies which OneLab still does not support. One technology that comes to my mind is, for example, IEEE has come up with a new 802.1 standard, which is called time-sensitive networking. In short, we sometimes call it as TSN, T time, S sensitive, N networking. So time-sensitive networking is an IEEE standard. All of you are IEEE members. You should go read about it. This is one technology that IEEE is working a lot on these days, and it's primarily used in automation industry, in automated cars, in smart grid, and all those places. We do not have a testbed for such kind of technologies yet in OneLab, but in future, they might come up with it. But we have IoT, we have wireless networks, we have for the internet in general, we have for cloud, and we also have for software-defined networks. So things like TSN are still not supported. So this is just a very quick walkthrough for all of you on OneLab. We don't have to spend too much time on that. Let me switch back to my PPT, and we'll need support again from all of you to raise your hands so that I can see that you guys are all able to see. Yeah, thank you all. I can see some people raising hand. Thanks a lot. Okay, so we briefly spoke about OneLab. Now, I mentioned to you that it supports so many different categories of testbed. We are going to focus only on one of them, which is called FIT IoT-LAB. I have not used the word FIT here because now you guys all know that it means Future Internet Testbeds. And we are going to specifically see this very large scale testbed, which is made for IoT experiments. The reason it is called large scale is because it has 1,500 devices. When I say devices, you will see later in the 4th bullet, there are 18 hardware boards that are supported. And all those hardware boards you can actually access remotely you can also upload your firmware. I'm going to show you how to upload the firmware, where are the options and all those things. But that hardware boards are available totally for free. Raspberry Pi 3, Arduino, Zollorita Firefly, and there are so many different boards that are available. And this 1500 plus devices that you see in my first sub bullet is actually referring to all these kind of boards. There are 18 different types of boards available, and they are available in multiple number. Like for example, there are 25 Raspberry Pi 3 boards or 100 Arduino boards. So collectively, 18 different types of boards. Number is 1500 devices in total. You can start these devices sitting from a browser here. You can stop these devices. You can reset them. You can flash them. You can remove the old firmware and you can install a new firmware, all of it without any expenses. There are 5 different communication technologies that are supported. For example, Bluetooth is supported. For example, Wi-Fi is supported, and there are so many different technologies supported. I'll walk you through all of the 5 quickly. There are 6 different operating systems that are supported by FIT IoT-LAB, and these operating systems are not the operating systems that we use in everyday life, like Windows or Ubuntu or Android. No, these operating systems are very specific for IoT devices. But all of them are supported in FIT IoT-LAB, 6 of them. And IoT-LAB is spread across in these 6 locations that you see. There are 6 different places in France where you will see this IoT-LAB, which is set up, and you can access any of these sites from here. So one is called Grenoble, then the second one is called Lille, the third one is Paris, the fourth one is Saclay, then Strasbourg, and then Toulouse. Toulouse was just recently added. You will see a blog which I will show it to you. These are all 6 locations, and the photos of these locations are available. How the sensors are deployed in the buildings, in which floor, how many sensors are there, are they organized in a linear topology, are they set up in a circular manner? All of that photographs are available, videos are available on YouTube, on their website. And more importantly, sitting here from India using a browser, you can actually configure mobile robots which are put up in this particular locations, and these robots will move along with the IoT devices, and that is called emulating mobility. So when we are moving from one location to another, we know that the connectivity often breaks. You can actually experiment with real mobility. There are these bots which are moving from one location to another, and you can see the results in terms of performance, whether the performance is improving or performance is becoming poor, and you can reproduce the experiments n number of times. So these are all fantastic features that this lab provides. Okay, so now I'm going to take you on a detailed walkthrough of the IoT lab. This is the photograph again taken from its website. I'm going to change over my browser to point to this website. Again, as I said, please do not create accounts, no matter how excited you are to see this, but control and see to it that you understand when you have to create an account. So again, I need some help. Everyone, can you please all raise your hands and confirm that you are able to see my new tab? Some more people, can you please raise hand so that, okay, fantastic. I can see 15, 16 people raising hand. Thank you, everyone. So going to this, I'll go to the right side button after a moment, the access the test bed, but you can see that we are in the home page and it says the very large scale IoT test bed. It provides a facility suitable for testing networking with small wireless sensor devices and heterogeneous communication objects. Don't worry about the complicated words that are there. I'll explain to you one by one all of them. So these are some numbers. You can focus on it for a minute. What they are trying to say is that this testbed has been right hand side. If you look at it, this testbed has been there since 2012. That means this testbed is now 10 years old. It's not something that has started now. And the PhD student about whom I'm referring to, who graduated with me, he joined in 2015 and completed in 2020, around that frame. So he started using this lab from that time. And there are 1500 plus nodes. Nodes means sensor devices, these boards that you see. And there are so many different countries that are using it. You will see this. First of all, it's an open platform. The testbed is open, free of cost for anybody to use. You don't need to worry about making any payments or any credit card details to be entered whatsoever, nothing at all. No payment, no credit card storing, nothing. Open software has been used and open tools have been used. We will skip this point right now, and you can see it says remote test bed, which is full of interactions, and it says you can do start, stop, reset, flash, and the one which is in yellow color highlighted here is going to be the most important thing for us in this session. They have made APIs which are REST APIs openly available for all of us, and using these APIs, we can perform direct experiments on this testbed. And that's why this whole thing fits into the API literacy program, because now you are learning how APIs actually can control the hardware and get you real statistics from the hardware or the network performance from the hardware. You can also find out power consumption of sensors. That means how much power did it consume, how many bytes were transmitted. All the detailed statistics can be obtained from here. But if I go down, you can see it supports multiple radio technologies. When I say multiple radio technologies, do not worry about the complicated words again. What it means is Bluetooth is supported, Wi-Fi is supported, cellular networks like 3G, 4G are supported. So you can see here, you have these technologies that are supported, which is called 802.15.4. It's an IEEE standard. We are all from IEEE. We know what IEEE standards do. IEEE standards always come up with new networking technologies. Like, for example, they came up with Ethernet long back, which is 802.3. Wi-Fi is also by IEEE, which, I mean, of course, there's a big alliance, but IEEE plays an important role in standardizing it, calling 802.11. So you can see these are all different things, low radio, the LoRa part, and all of them are supported in this testbed. Quickly moving forward, that how many platforms are supported? There are 18 different types of boards that are available. You can see there are microcontrollers available. Then there is this Zolarita sensors that are available. And then if you click on this button here, which I don't want to go right now, I'll take you there later. Show all. It will show you all different hardware that is supported, and more importantly, they have very nicely told which hardware is supporting which radio technology. So, for example, if you see the first one, IoT-LAB M3, it is supporting 802.15.4. These two are also supporting that. But if you look here, it is supporting Bluetooth also, the Nordic one. Or if you look at Zolarita Firefly, it is also supporting sub-gigahertz technology. So if you go to show all, for all 18 hardware boards that are available, they will tell you which technology is supported and which technology is not supported. Go down, there are multiple operating systems that are supported. These operating systems are something that you all might have probably not been very familiar with. But what you need to understand in today's session is that these operating systems are not the ones that we use in our day-to-day life. Like, for example, we use Windows, Android, iOS, Ubuntu, or Red Hat, or some other operating systems. But these are some unique names. The most popular one is RIoT. Again, IoT actually stands for the Internet of Things. So RIoT is a real-time operating system. There's another one called Zephyr, which is under Linux Foundation. MicroPython is another operating system. These are all open source operating systems, by the way. You can actually download and play with them. Then there is FreeRTOS, you can see here. Contiki is a very popular operating system. Earlier, it was just called Contiki operating system. Nowadays, it is called Contiki NG. You can see here, which is written as -NG. So this is again an open source operating system. Yocto is another operating system. These all operating systems, you don't have to install on the hardware. They are all there for you to use. You just need a web interface and just start playing with it. So this is a quick walkthrough about it. And these are the locations, all of you, which I told you, the Grenoble, Lille, Paris, Saclay, Strasbourg, and then Toulouse. And if you go and take your cursor on top of them, they are all clickable. They'll show you the entire setup of that particular lab. So let me just take you to one to show you. Let's say go to Grenoble. And when I click on that, it takes us to a different web page where they have told what are the things that are available. So you can see they have mentioned what is the server. So the website which I opened in, if you looked at my PPT, it was called IoT-lab.info. Now the name of the site is in front of it. So it's called grenoble.iotlab.info. That's the server. And there are boards. So these boards are supported in that. You can see Raspberry Pi 3 is supported. So far, they have not supported Raspberry 4 in any of their 6 sites. Raspberry 3 is there, which is still good. We don't need necessarily Raspberry 4. And then we have microchip, we have IoT-LAB M3, and in bracket, whatever numbers you see, in case you see that numbers are not visible, I'm just zooming in. You can see that they have written 228, means 228 boards are available for M3 category. And this is A8 M3, which is slightly different than M3. You don't need to worry about the architectures of that. And then 5 Raspberry Pi boards are available. And now you can see they have given the detail. And let me try to zoom out a bit. And you can see the layout of this site is provided. And on every corridor and in every floor, how many devices are located, and in ceiling, how many devices are located is explained here. Again, and they have marked it. Like, for example, this is the, on the right-hand side, which I'm circling, which might appear after a moment to all of you, this J. This is the J floor or the J corridor. Then if you come towards left of it, this is F1 corridor. This is F2 corridor, then F3, F4, G corridor, K corridor, and how many sensors they have deployed and how many boards they have deployed in all of these corridors has been given. This is only for one site. Like this, they have given for all the sites. You can see on the extreme left-hand side, all the sites are listed here. If you click on any one, let us say Paris, then a similar web page will open for Paris. And then they explain that there are only 2 different kinds of boards that are available in Paris. One is A8 M3, one is M3. 62 and 69 are the total number of boards that are available. And you can see how they have deployed photographs of that are available. And this is just the beginning. If I spend maybe another 3 hours on this website, even still you people will find it less, because there is so much information that they have arranged systematically and put it over here for us to use. So now what I'm going to do is I'm going to go back to the home page. It will take a moment for all of you to pop up. Once I go to home page, now is the time when we will start playing with the actual stuff. So I'm going to go and show you a demo. And this is the docs where you can get all the documentation about this. So you can see there is a button called Getting Started. And it just gives you a brief introduction. Whatever I have been speaking, they have summarized it here. There's no need for you to worry about it. They talk about SSH access. You don't need SSH access right now. Don't worry. You will see that I'm able to just click and get the sensors up and running. So don't worry about SSH. That is where you have to make a note that, okay, SSH is mentioned there, but it's not needed. I want you to spend some time on this design button. I have clicked on it. It will take some time. And now you will understand where is the API in the whole system, right? So I'll take a minute to check with all of you here. Can some people raise hands? Are you able to see the architecture diagram, which I have opened up in the web page right now? Okay, perfect. Thank you. So you can see here, you are on the left-hand side. So this point where my cursor is right now is we people. Okay, we are sitting remotely. And what you see here, nodes, which are, put up like here, like the chips, you can see, these are the actual pieces which are on 6 different sites. So you can see they have given diagram of 3 sites, but there's ... here. So essentially there are 6 sites about which we were talking recently. And each site has several nodes. And we can either connect to all these sites and operate on the nodes using SSH, which is not needed as on today, unless you become a full-time user of this lab and you want to explore a lot of technical details. You don't need SSH. The right-hand side at the top, what you see is sufficient for today's session, where we are going to use a web portal and we are going to send HTTP request via the API. So you can see in a restaurant experience now, these are we people who want to eat the food. This is the kitchen where all the devices are. And this is the waiter who is going to take the call. So we will make an API call, and the API calls will internally be directed to a respective site wherein we request. So you will soon see by the end of this session, I will show you how you can make an API call for, let us say, Paris. Or let's say you don't want to go to Paris, you want to go to Seclay site and perform experiments. So you can specify in your API that I want to perform experiments on the Seclay site, and APIs are available for all of those purposes. So this is why we are having this session in the API literacy program, so that you all know that hardware can be controlled and how beautifully the team of Fit IoT Lab have made it available to us via API. And I'm so happy that so many researchers can actually make use of it. So if you want to go in further detail, I'm scrolling down. I'm not going to spend a lot of time on that because I want to spend some time showing you how to actually run the test bed, how to select the nodes and all. But if you want, there's a lot of information available. Like, for example, how have they integrated the hardware, right? How is the hardware integration done? So they have explained how they have created a gateway, how they have created an open node, how they have created control node. They have given the diagram. For example, you can see this is something like what you people might have observed, like an Arduino board or a Raspberry Pi board looks like. Okay, so you can see they have explained that where is the node and which one is a gateway and how they have configured and how the interaction happens. How are they getting the power supply? What happens if there's a power cut in this site? How will these nodes keep working? All of that information is available, and some high level technical details are provided, which we don't want to spend time on. Now, let me go back to the left hand side, and now we were in getting started button. Now we'll go to the boards, and you will see that there are so many different boards available. Again, a quick check. Can you all see the boards on the left hand side like IoT-LAB, M3 and stuff? Can you please raise hands so that I know that you are able to see different boards listed on the left hand side? So if you want to find out the details of the boards, you can see there's a table here. For example, there is Arduino 0, and it supports which technology? 802.15.4. For example, now BBC microbit, it does not support 8015.4, it supports Bluetooth. Similarly, Decawave supports Bluetooth. So the dot mark means which technologies are supported in which board. So you can see the most popular board that my student was using in his PhD on IoT was Zolarita Firefly. Then we were using Raspberry Pi 3. We were using Arduino 0. You can also use anyone. And I'll show you how you can select such kind of boards in the experiment. You have the flexibility to select all the boards. So that's boards. Then deployment, I already showed you the deployment. There are 6 different sites. So let us not spend time on that. And there are some tutorials in this learn button. You can go and look at this tiny little 2 minutes YouTube videos. How do you conduct your first experiment as a beginner on this? And you don't need to do any SSH or any such thing. Okay. So now let me go and show you how I access the testbed. So let me click on the home button. Please give me a confirmation that you are able to all see the home page right now. And if you are able to see the home page, okay, perfect. I can see people raising hands. So now you can see on the right hand side, it says access the testbed button. So I click on access the testbed. Because I'm signed in, it did not ask me to sign in again. Otherwise, it will ask you a pop-up and you will have to sign again. Now you can see the dashboard right now. So can you all see these buttons very clearly, like 0 running, 0 scheduled, and 3 completed? Can you all raise hands quickly so that I know that you are able to see my dashboard and I'm already signed into it? Okay, perfect. Thank you. I can see the hands going up. Now, I was preparing yesterday for today's session to show this demo. So you can see the date is available. It says 4th August. So please read it from right hand side to left hand side. So it says 4th August 2023 at 11:51. I completed one experiment whose name was demo firmware, and I started performing experiments at 23:28. Then I performed another experiment at this time, and you can see it tells me for how many minutes these experiments were running, and you can also see how many nodes I selected for every experiment. And by the way, it doesn't mean that the experiment is completed, so now everything is gone. Actually, I can go on this button, which is here, and I can click on it, and I can say view details, and it shows me all the details of the experiment that I had conducted. So for example, it gives you my username, then it says what time the request was submitted to start the experiment, what time the experiment was started, what was the experiment, when was the experiment stopped, how much was the duration, whatever the number of nodes, and then you can see it tells me exactly which nodes I selected. So let me explain to you in a minute. IoT-lab.info is the name of the website, which is the main website. Since it is having the word Leel, means out of 6 sites that I discussed yesterday night, I was performing experiments on Leel, and M3 is the name of the board that I am using, which I was referring 2 minutes back, and 100 is the number of the node. That means this node which I got, its number was 100, another number was 101, and I got all of them in sequential order from 100 to 108. So consisting of totally 9 boards were allocated for me for this experiment, and I uploaded a common firmware on all of them. Okay, you can see that this firmware is made available by this team for learning purposes. That is why the name is called tutorial. And why is it called M3? Because it is a firmware for the M3 board. So you need to know which firmware belongs to which board. And for them to ensure that you don't do a mistake, they have used that word M3 so that you know that M3 means this is for, so you can see the node name is also M3 on the left-hand side. And the firmware is also M3 so that you know that you are uploading the right firmware on the right node. Okay. And you can see that the deployment was a success, means experiment did not fail. I can always go back to my dashboard by clicking on this button at the top, which is called My Experiments. And you can see that now again, I get the summary of all of it. Okay, then the next button is the plus button that you see. Plus button means if I want to add a new experiment, which I will do in a short while. But you can also create your repository and keep it. So you can see this folder icon. It is called My Resources. When I click on it, you can see it tells me how many firmwares I have uploaded. You can see there is no firmware that I have uploaded because yesterday night I did not have a firmware with me. Tomorrow when you people will practice, even you will not know from where to get the firmware. Don't worry, you can see there is a button called presets. So when you go to presets, they have given you some sample firmwares which you can use for your experimental purposes, right? And for example, the firmware that I used yesterday was M3, the one that I'm selecting here. Okay, so if you use Arduino, which is listed second in the row, then you should use the firmware called, if your architecture is Arduino 0, then you have to select this firmware. If you are using Zolarita Firefly, then you have to use this firmware. And similarly, you can use many other firmwares which you want. You don't need to find out firmwares from the internet and upload it. But once you start working with this lab and you want to keep your firmwares in one location, they have given you one storage where you can keep your firmware and use it in your experiments. Now, let me show you a very interesting thing. The one that you see here, the rack symbol on the right, is called the testbeds. And now this is the live experimental status right now. I'm not running the experiment. I'm checking how many nodes are there. So can you all confirm that you are able to see that the blue color button is there on 6 sites? Can you all confirm that you are able to see that, so that I'll quickly move and then show you the rest of the icons? Okay. Now this is a live status of the testbed. And when 6 sites are selected, that means it's a summary. Totally, there are 20 architectures. All of them are selected. And right now there are 1,534 nodes. 1,476 are available, means they are free. You can use them right now. 32 are unavailable, means somebody is using them right now. You can't use those 32. 26 are dead, means they are powered off. They have some problem. Now look at the beautiful information that they give here. For example, this is architecture A8 in Grenoble site, and it is alive, means you can actually use this particular device. And the site name is mentioned, the architecture is mentioned, and the power control is given. You can turn off, turn on, you have power consumption, so how much battery is remaining. And then they have given the 3D location of it, x-axis, y-axis, z-axis. So you can know that, if it is a vertical arrangement of the sensors, one on top of each, you will know based on X, Y, Z that which one is on the left, which one is on the right, which one is at the top, which one is at the bottom. So all of this information is available. But I want to, now select, let us say, Leel. And in Leel, now you can see there are 3 architectures that are supported. So the moment I clicked on Leel, it's telling me that there are 3 architectures. Totally, there are 281 nodes. 262 are available, 8 are currently under use, and 11 are dead. And now I want to see how this site looks like on a map. So I click on this, and you can see these are the live locations of these sensors. Can you all see these green color dots? Can you please confirm that you are able to see the green color dots right now that I am showing in my machine? These are actually live locations, and the green means these ones are available. Red means they are not available. Okay, and then there are certain which are dead. So you can actually play around with the view, and you can see the different ways by which they have made it available to you. So you can see this is like a color arrangement and all of these. So there are some sensors at the top, there are some sensors at the bottom, and now I'm playing with the 3D view of this. And you can do this for all the 6 sites that we have right now. Okay, you can play around with all of them. Now let me take a minute, go back. Enough of fun playing around with the live locations. Now let us go and start running the experiments. So what I'm going to do is I'm going to add a new experiment first of all. So I click on new experiment, and it's asking me new experiment name. So I'll say session 3. Okay, it says that you are not permitted to give alphanumeric characters. So it says space is not permitted. So I say session 3. So now it's okay. I did not get any message. 20 minutes is quite a lot of time. We don't have that much time right now. I'll just run it for 1 minute. Okay, you can also run it for hours, you can see. And there are 2 options that I have. Do I want to start this experiment as soon as possible, or I want to schedule it? Let's say I want to schedule it for tomorrow morning. So I configure the experiment right now and give the time, and it automatically, see, I might be sleeping. So right now it is about 6:48 p.m. I might be asleep at night, 2 a.m., 3 a.m. And what I can do is I can schedule the experiment for 2 hours starting at 2 a.m. India time. By the time I wake up in the morning, this experiment might have completed. 2 hours might have exhausted. So I can schedule also whatever I want. Okay. So now you can see I have chosen for all of you to see right now as soon as possible. So I will not do the schedule. Now I click on this nodes option. And when I click on the nodes option, it gives me lots of things. It tells me which architecture do you want, which site do you want. So let us take the same site which I had taken yesterday, Lille. And then I say the architecture that I want is, let us say, M3. Again, you can see all different architectures are available. And then now when I selected M3, it went into Grenoble because M3 probably might not be available, or they might be available at Lille. Let me see whether it allows me to configure. It allows me to configure. And now it says how many you need it. So I say, okay, this time, let me select 12. So I say, I need 12 of the nodes right now. And then if I want to particularly pick something from sites, I can do that. I don't want to spend time. If you want specific nodes, you can actually specify that please give me a node which has a number from 103 to 108. We don't need that much configurations today because we are learning only basics. So we don't need to specify all the details. And then, so I select the architecture as M3. I select as Lille. I select as 12. And then I say add to the experiment. So now see, when I said add to experiments, it tells me that they have selected 12 nodes for me. Now let's say I did a mistake at this step. I can click on clear all, and I can reconfigure the number of nodes, the site, or the architecture. And all of them are M3. Okay. I can also add more number of nodes. So I can say I have 12 nodes of M3. I want 5 Raspberry Pis. I want 5 Arduino. I can keep adding more and more to the experiment, and all these nodes will keep getting added here. But I don't want to make it super complicated today. Just I'm adding all M3 nodes, and then you can see multiplied by 12, and it gives me an option, add firmware. You can see here. So now add firmware is one option. Second option is add monitoring profile. I'm not going to add monitoring profile today. I'll just click on this chip button, which you see tiny little, which is besides 12. I'll click on add firmware, and now it says, okay, select which firmware you want, but I don't have any firmware right now. So what do? I go to presets, and there is automatically a firmware which they have selected for me because I selected M3. So they have already shortlisted M3 for me, and they are not allowing me to get confused, which is good. So I just select this, and now you can see my firmware has been added. So now my experiment is ready to go. So I'm going to now submit the experiment. Now you can see at the right, now you can see the state is launching. How many of you are able to see this state launching? Can you raise your hands, please? So that I know that you are able to see the state launching. Fantastic. Okay, great. Thank you. So now this state, will change because I have taken some more number of nodes. So now it says running. You can see it has changed to green color running. It might take a minute for all of you to see it. And now you can see the duration of this experiment has started. It says 1 minute, the experiment will run. Meanwhile, all of this is happening. I can click on this green button and I can say stop, or I can say view details. And you can see I can start them. I can power them off. I can reset them. I can also flash a new firmware. While the experiment is going, you can stop certain devices if you don't want. You can restart them if you want. All of these options are available. One by one, you can perform action on all the nodes, or else you can select this button at the top and perform a common action on all 12 nodes. Like all 12 nodes, please stop right now. You can do that. Immediately it will stop. Okay. Or all 12 nodes, please upgrade the firmware or take a new firmware. All of this can be done by using this particular interface. Okay, so let us now see. It's showing now that 1 minute is completed. Now see the state has changed to finishing. That means it's closing all the devices. It is cleaning up the devices, and it will change the state soon to something called terminating or terminated. Okay, in my system, I can see it has terminated. How many of you are able to see that it has terminated? Can you raise your hands and confirm that you are able to see that it's terminated? Yes. So now that means that I have, completed this experiment. I did not give a monitoring profile today because of the shortage of time. What is monitoring profile? You can say that I want to monitor the power consumption. So when 1 minute experiment was running, how much power was consumed in sending packets or receiving packet, or sending a signal or receiving a signal. I have not done any of that, but if I would have done that, I would have just clicked on this download button. It will download all the statistics to me, and it will give it to me in the JSON format. So this is how easily you can actually run experiments. I took 12 nodes right now. Actually, 12 pieces of hardware were triggered by us right now in this 1 minute. And you can see that these are the nodes that we were allocated. And this was the firmware that we uploaded in the experiment. Now, when I click on the dashboard, now this experiment will go into the archived state, saying that you have completed 4 experiments. You can see there is load more option. If I click, now you will see this one which we completed just now. Okay, you can see. Okay, it has just changed the state. I'll refresh the page, it will come through. So you can see now there are 4 experiments which are completed. Earlier there were 3 experiments which we had completed, right? So you can run all of these experiments and collect the data. Now let me take you to an interesting point where what this team has done. So this team has provided to us all of this possible through an API. So I'm going to click on API documentation, and you all will see something that you have been learning. So this is a REST API documentation that they have provided. How many of you are able to see the REST API documentation? Can you raise your hand so that I can confirm that REST API documentation is visible? Okay, thank you. So now you can see that REST API documentation, and they have given the server. So please remember, when they have given the server, that is their endpoint. Okay, and that is their URL. You learned with me in session number 1 what is a URL, and you can see they have told you that which method you have to use. So get method, and then you have to give this path, that is /experiments/total, and it will return the total number of experiments. You don't need to go to Postman right now to do this. You can actually do it right now. I'll show it to you. Okay, let me go down a little bit, and I'm going to select something, and then I'm going to ask you people to confirm whether you are able to see it. Okay, can you see that I have reached the window where nodes is available in black color? Can you confirm quickly that you are able to see the black color nodes? Okay, so now what I can do is I can click on this nodes, and you can see it expanded. Okay, can you all confirm that you are able to see the parameters on the left hand side? Maybe quickly so that I can, yeah, okay, perfect, thank you. So you can see now, you used all query parameters in Postman classroom program. So these are the query parameters. The name of the query parameter is site and the value is all. Similarly, the query parameter is archi, which means architecture, and there is a value that you can provide. Then there is a state, and you can say that I want to find all the nodes which are alive. Alive means basically they are right now on, the green color nodes which we were seeing. We can also check the dead, means the ones which are switched off. So let us click on this button called try it out. And when I try it out, you see that it becomes editable now. So I will say that site can be all. So all 6 sites, Grenoble, Paris, Saclay, everything. I want to know only how many nodes are alive. So I click on this and I say alive. And then I click on execute. So when I click on execute, you can see it's loading. It will take some time. And now it gives me a response, which is 200 code here. And it tells me in the JSON format that, okay, all the ones that are alive. And this is coming from site, which is Grenoble. I can go back. I can say, now give me all the ones that are actually dead. That means they are not working. I can again say execute. When I click on execute, it comes down and now it shows me all the ones that are actually dead. Now, all of this you can do from here, but that means that you can also do it from Postman. So it's high time that we migrate our tab to the Postman tab, because that's what we are most comfortable with because of the program being using Postman from beginning. So I'm now going to take you to my Postman tab. And I want all of you to quickly raise hands so that I can understand that you are able to see my Postman tab. Okay, you are able to see my Postman tab. Thank you. So now I'm going to my workspace, which is called IoT-LAB. I have prepared this workspace and I have kept one collection ready for all of you. So that a collection is called experiments of IoT-LAB. And I have used 4, requests, which are all of category get. So in the first one, you can see when I click, you can see here the API endpoint is what they provided to me. And then I just added sites. And when I click on send, it says sending request. And then it will give me the reply saying that we have, okay, let me take this a bit up. So you can see there are 6 sites. One is Strasbourg, Paris, Toulouse, Grenoble, Lille, Saclay. So all these sites are available. I want to know the details of the sites. So I'll go to the next request on the left-hand side here. And now I just added the word details. In the previous request, there was only sites here. You can see at the end. Now I just added /details and I send a request to this link and it gives me all the details. What are the details it gives me? Let us scroll up. It says that in Strasbourg, you have these architectures and none of them are mobile. None of them are mobile means they cannot move. How many are there totally? There are 14. Okay. There's another architecture called M3. There are 64 M3 hardwares. Then there is something called Arduino Zero, which are 12 in number. Then there is PyCom, which are 10 in number. So all of these are coming in JSON format and we can look at it. Now I want to go to the third request, which is called list of nodes. And I just put nodes here after the endpoint. Endpoint ends at API, which was given on their website. I click on send, and now it will give me a JSON object with all the details of all the nodes that are available. And this is a very long list. This is 1,500 plus list. So I'm not going to scroll down and show. But then if you want node IDs in integer, you can just add IDs after nodes and make a send request using the get method. And now it says, okay, in Strasbourg, in this architecture, the node IDs are 1 to 14 and their state is alive. You can also put a query parameter here saying that I want all the ones that are dead. So let me do that. I go to the list of nodes. I take this down and I add a key here and I say state and I say dead. And when I say state equal to dead and put I say a send, then I get a 200 OK response. And now it just sends me all the information about which devices are right now not working and from which site they are. I can add one more query parameter here. instead of saying state, I can say, okay, I want to know which nodes are dead in Lille site or in Grenoble site. And then you will be able to find all of that information. So this is how we can actually play around with these APIs through Postman, and you can incorporate and develop a nice little application where you are able to contact IoT-LAB, and you can have a mobile application developed which gives you easily configurable parameters on your mobile, and you can run experiments on real hardware using a mobile app. That can be a fantastic project as well. So now I'm going to go back to my slides. Once you all start seeing the slides, please let me know so that I am aware that you guys are all in line with me. Can you raise your hands and confirm that you are able to see my slides, please? I can see only 979 people. Okay, yeah, perfect. I think that is good enough. So now what I'm going to do is we are going to the next step. This link, I already showed it to you. This was the documentation one. What I'm going to do next is it's the quiz time right now. So we all have to go to menti.com. Please go there, all of you. And in a minute, I will show you the code so that you all can reach that code. Okay, so this is your code to join the quiz on menti.com. So please go on this link and then click on, and please give your name and college name so that we know that who is participating, and enter that code. And please give thumbs up so that we know how many people are coming. I'll give you a few minutes and then I will start the quiz. So I can see some people are logging in. Please keep going. Yeah. Yes, I can see a lot of people joining in now. Keep going. I can see we have crossed 35, but we have about 90 people in the call. So let me give a couple of seconds more so that we don't miss out on anybody. Yeah, we have neared 50. Please keep going. We want all of you to participate in the quiz. All right. So now you can see that we will have players that are ready soon. And I'm going to press enter to start the quiz. Okay, so be ready. In a moment, you will all see a screen coming up with questions. So, which architectural style has been used by IoT-LAB to provide its APIs? You have 30 seconds to answer the question. First option is SOAP, second option is REST, third option is GraphQL, and fourth option is gRPC. Which one do you think is the correct option? Please enter your answers. Everyone has voted. Fantastic. So let us see now the results. Great. More than 43 people said that REST is the correct answer. Yes, REST is the correct answer. IoT-LAB does not give you SOAP or GraphQL or gRPC. It just gives you REST support. So let's move on to the next question. So next question is also again going to come in front of you soon. Yeah, so wait a minute. Which of the following is not supported in OneLab testbeds? So we discussed some testbeds today when we started the session. 4 options are there: wireless systems and applications, IoT, time-sensitive networking, cloud-based platform. Which one is not supported in OneLab testbed? Okay, we have last 10 seconds to go. I can see more than 50 people have voted. 56 people have voted, 7. All right. Again, majority of the people have voted right. 27 people have said that it is time-sensitive networking, which is not supported. Yes, you are right. Uh, Wireless systems, IoT, cloud, all are supported by OneLab. Only time-sensitive networking is not supported. Let's go to the next slide. Be ready for the next question. So the next question should be there in front of your screen in about a few seconds. Which of the following board is not supported in IoT-LAB? Please remember, not supported. Raspberry Pi 3, Arduino Zero, Zolarita Firefly, Raspberry Pi 4. Which one is not supported in IoT-LAB at this point of time? Last 5 seconds. Keep going. Very nice. About 29 people have said Raspberry Pi 4. Yes, that's the one that is not supported. All the other 3 are supported in IoT-LAB. Okay, let's go to the last question for today. It should be up in a few seconds. Which of the following operating system is not supported in IoT-LAB? 4 options: Windows, RIoT, FreeRTOS, Contiki NG. Which one is not supported in IoT-LAB? Ten seconds. Keep going. That's right. Windows operating system is not supported because Windows is not actually meant for IoT devices. So it will not be supported in IoT-LAB. All others are supported in IoT-LAB. So let's see who wins today. And fantastic. People keep going. People keep going. Right. So we have Ashwini, 3871 as the winner. There are so many of them, apart from them, that who are in the top 10. Sujan, Fidan, Ajwin, Melson D'Souza, Hari Kishan, Maitri, Sahana, Giridhar Kini. Thank you all for participating in the session. Let us get back to our slides. So all of you come back to the slides and let me know whether you are able to see the hands-on practice screen. Can you please confirm, all of you, by raising the hand that you are able to see my screen? All right, thank you. So now again, 104 people have completed the Postman Classroom program. Those who have not, please complete it. Otherwise, you will not be eligible to participate in the project competition. Do not create an account on IoT-LAB unless you are really interested and willing to do something useful. Don't unnecessarily go and make your institution in risk of getting blacklisted. Please go through the API documentation of IoT-LAB, the one which I showed you today. I'll also be sending in the email. And then please try those APIs in Postman the way I tried today in Postman. So you're actually making requests to those sites in France and you're getting the data from physical locations. So it's a real use case of API. So with this, we come to an end of the training session. All 3 training sessions have been completed. I'll be sharing the details with all of you. And after this, as a next step, you will get an email from us. Again, those who have not completed the Postman Classroom program should be completing it first, and then only you become eligible. We will send you the rules and regulations, but just to inform your friends, from tomorrow onwards, you can start forming your team, thinking about what projects you have to do. You can do projects which use the existing APIs. There's no need to worry about making new APIs in the project competition. If you want to make new APIs, welcome. You want to use some of the existing APIs, that's also totally fine. We will send you the instructions by email. Get your teams ready, get the projects ready. The timeline to submit your team details like team name, member name, completing Postman Classroom program, you will have to give us the links once again. All of that is August 10th. After August 10th, we will not be taking any more teams for projects. 11th onwards, your project starts. Please remember, having one faculty member is important. There can be multiple faculty members. One has to be an IEEE member at least among faculty. Okay. The second one need not be an IEEE member. So with this, we complete our all 3 training sessions. Thank you all for being present here. Just to let you know, there are more activities coming up from IEEE Mangalore subsection. We are soon going to do a curtain raiser after your exams are over, after 31st of August, talking about the new program in collaboration with NITK, which is called NITK Winter of Code. And we'll be also conducting sessions on how to apply for Google Summer of Code. So stay tuned. There are a lot of things going to come up. For now, if anybody has any questions, please raise your hands or put it in the chat box, and I'll be happy to answer those questions for all of you. So I'll wait for a few seconds to see if anybody wants to ask any questions in the chat box, or raise your hands, and then I can allow you to unmute and you can speak. Let's give a couple of seconds for people to ask questions if they want to. Okay, let me do one thing. Just stay with me here, all of you, until other people are. So let me do one thing. I'm allowing the microphone for all of you. Anybody wants can unmute and talk. But by the way, since we are closing the session today, this is the last session that we are talking. Let's take some photos. So all of you who can turn on your cameras, please turn on your cameras. I have so you can turn on your cameras, and we can all take a couple of photos together, just in case. So I can see some people turning on the camera. Please go ahead and turn on the camera. We'll have some quick photos taken. And if people want, they can put a question in the chat box. I request some more people to turn on the camera so that we have some nice pictures taken. Yeah, keep it on. I can see a lot of screens coming up. I'm waiting for a few more people. All right. Thank you, everyone. Thank you all for attending these sessions. You can put off your cameras now. Thanks once again for attending all the sessions, and looking forward to having all of you participating in the project competition. And if there is any doubt, you have the email addresses to reach out to us. Thank you all again. Looking forward to project detail submissions from all of you before August 10th. Bye-bye, take care, and have a very good rest of the weekend. Bye-bye.